This is my quiz video, and I'm gonna talk about one of my team members' topics 1 through 4. We'll start off with topics 1 and 2, hydrostatics and buoyancy. So we have a dam that the pressure profile increase as the depth increase, and we want to calculate the total force acting on the dam in meganewtons. Here's the picture of that. And also for the buoyancy question, we adding some shade balls to the water to kind of decrease the evaporating of the water from the dam, and they are like partially submerged underwater, so we want to calculate the volume submerged as well. So let's take a look on the solutions on those. So on part 1, the assumptions is that it's incompressible fluid and works in the cage pressure and not completely static but slowly moving, hydrostatic. And we got the properties from handout 1. The major equation is that F equal PA and P is rho G H. So we get the integral because it's increasing the profile, and we can calculate the total pressure that is like around 2000 meganewtons. In part B, we have to find the density of the single shade ball and the volume of water displaced. On that, we assume it's incompressible fluid and stationary fluid too. And we use the Archimedes law to find the volume of water displaced. And also we can find out the density because we have the mass of them. For topics 3 and 4, the the Bernoulli and the momentum balance, we have a automatic car wash that they pump the water from a lake to the top, and from tank 1 it goes to tank 2 and do the filtration, and from tank 3 it's gonna use the jet to do the water to the cars. So for the Bernoulli part of that, we want to calculate the work that pump need to do to get the water on the top. And also on the macroscopic momentum balance, we want to see what force we need to like cancel out the force that water comes as a jet out. So on the Bernoulli's equation, we have the extended form with the work and shaft work. We assume the flow is steady and incompressible, and the elevation difference between lake and tank is constant. We get the properties from handout 1, and here's the Bernoulli equation, the extended form, and we get the cancellations that you can see. P1, P2, same, the density is the same, and we cancel out to get the W shaft, and also we get the ETA pump too. On the macroscopic momentum balance of that thing, it's on page 17 right here. We assume flow is steady and incompressible, constant density. The window is vertical and the jet is normal to the window, and friction of motion is negligible. So we write out the whole momentum balance equations, and we can get the velocity as well that water hit the window of the car. Thank you so much.